Hello, and welcome to The Confident Commit, the podcast for anyone who wants to join the conversation on how to deliver software better and faster.
If you're looking to build a trusted ship, tune in, let's confidently commit.
Listening to episode 8, season 2, I'm your host, Rob Zuber, CTO of CircleCI, the industry leader for all things CI and CD. Today, I'm joined by Justin Reock, field CTO at Gradle. Justin, thanks so much for joining me. It's awesome to have you.
Rob, thanks so much for having me here. Looking forward to talking with you today about developer productivity engineering.
Let's not waste time, then let's jump right in. So I love that that notion that y'all are focusing on. I mean, we're thinking a lot these days about, we're always thinking about continuous improvement and being able to deliver faster and better. In particular, we're thinking about learning from failure, and I see lots of references to failure in your framework. So I'm excited to get into all of that. But just to kick us off, I think it would be surprising if people weren't super familiar with Gradle, but give us like the 2 seconds on Gradle, and then how, as an organization, you found yourself really focused on developer productivity and developer productivity engineering.
Sure, yeah, definitely. So Gradle Inc. really represents two separate entities at this point. We're the team behind the open source Gradle build tool, which is, of course, a really well-known build tool, very popular. It's the default build tool in the Android SDK, and used by a lot of folks, has a lot of good reasons to use Gradle. So that's one part of our business. And then the separate part of our business, more the commercial side of our business, is our Gradle Enterprise product. Now, this is a product that's completely separate from Gradle. It's not a build tool or like an enterprise version of Gradle or anything like that. Rather, it's a set of enabling technologies for the practice of developer productivity engineering. So it can integrate with build tools like Gradle or Maven or Bazel most recently, and provide a lot of the tooling that supports sort of the mindset and philosophy that developer productivity engineering is.
So tell us a little bit about that then. Like, as you think about developer productivity, and I'm going to project a little bit, but feels like you're looking at it from the lens of building and software delivery, which is
Sure.
a lens I'm particularly excited about, obviously, but it's a piece of the puzzle. Like, what is that mindset? What are you hoping to bring to people, get them to focus on, and get them to really try to drive towards improving?
So I think, to kind of sum it up in terms of like the why of why we would put a practice out there, we're at a state now in the industry in 2022 where 65% roughly of the entire global GDP has been digitally transformed at this point, which is staggering if you think really the amount of code that represents, and then the workforce that supports that amount of software. And obviously this software is supporting all types of other verticals and industries, right? I mean, everything from healthcare to consumer retail, software is now driving and transforming, kind of all of these businesses. And yet we're in this position still where basic stuff like feedback cycle times for developers, are still in a lot of cases, painfully long, or at least in our mindset, not as fast as they can possibly be, given all acceleration in analytic and observation technologies, right? So I think the DPE mindset is very much about, despite all of the great stuff that things like DevOps and previous to that, Agile and Lean and all these principles that have been put in place to really help parts of the SDLC process as a whole, that the industry has really shifted its focus over the last few years to look at what we think is sort of the next big consciousness for the industry. And that's, how can we improve developer productivity, right? So we look at this as like the next shift in consciousness after DevOps. And that doesn't mean that, it's only for DevOps mature organizations, right? And it doesn't mean that, DevOps doesn't still have a lot that it can innovate with and grow. But it's now we have another layer that says we found a new set of bottlenecks. We found these bottlenecks and friction that are distinctly part of the developer experience. And these are things like long cycle times, long test cycle times, avoidable failures in the build that, force developers to have to, wait until they're getting feedback, inefficient troubleshooting tools, which, failures are not necessarily going to take a developer out of that state of flow or that really productive state that they're in, as long as there's good tooling to solve those problems, right? I mean, the software development as a behavior is very much a right brain and a left brain type of activity all at once. We have creative problem solving, but at the same time, we're making a hypothesis with the language or framework about whether the code that we're writing is going to solve the problem, whether it's going to put some pragmatism behind the creative idea that we have to solve the problem. And if at any point we reach a state where the tooling or the idle time or the context switching is too much to the point where that developer is taken out of flow, we now have a state that's deleterious to developer experience, right? So I think that the why of this is pretty clear. It's that we still have a lot to do in terms of making sure that all software developers are experiencing cycle times that are as fast as they can possibly be, not fast enough, but as fast as they can possibly be, given all applied technologies, and that we have the right type of tooling for developers to stay in flow even when they run into trouble. So then, the how and what is very pragmatic: acceleration technologies, analytics technologies, and observation.
And I mean, I think you covered a little bit of it in there, but as you've experienced this, right, as you've gone out into the field and worked with some of your customers, talked to, I'm guessing, folks that aren't your customers, but trying to understand the use case overall, have you found that that the gaps are primarily in tooling or in desire, understanding, or some combination of those things? Like, is it that people don't know that this is important, or they know it's important and they just don't know what to do about it or have the capabilities to do something about it?
So the solution is always going to be in the tooling, because this is distinctly developer productivity engineering, right? This isn't something where we would look at redesigning human behavior processes to try to lean on developers or whatever that would be. So this is very much an engineering type of answer for it. But in terms of where does this really stem from, a lot of it is that if you go and ask the average organization, are you even tracking local build times for developers? Are you even looking at how long developers are waiting for build cycles to complete or test cycles to complete? A lot of people, I've gone on the road and I asked that question as part of our keynote on DPE. How many of you are tracking this as of now? And it's like crickets. It was funny. The last time that I gave this talk was out in Stockholm just a few weeks ago for JFocus. And I think the only people who raised their hands were people who were already customers or were already we knew of were working within the DPE kind of mentality. So, but it's also this other thing that when you look at it, it's such a no-brainer. Like one of the best bits of feedback that I got was at another conference giving the same talk. And someone came up and said, that was the best talk I've seen in a couple of years as a DevOps professional. I really appreciate all of what you're saying. But it's also one of the most frustrating talks that I've listened to in a while, because at every point you're making, I'm kicking myself thinking, why weren't we already doing this for our developers? So I think that DevOps professionals are very hungry always to improve the developer experience. But I think this is, again, just a set of bottlenecks and friction and obstacles to throughput that are just sort of being discovered, if you will. Somebody finally stood up and said, things don't have to be this way anymore. So,
and is there something in particular that you're able to connect for folks? So if you say, are you tracking local developer build time, right? Particularly if you said that to, I don't know, I'll play the role of the CTO here. It's not hard role play for me. I might say, no, why is that a problem, sort of thing? Like, I wouldn't, but let's pretend that's the scenario, right? So, so then what's the connection that says, okay, maybe you don't see it as local developer build time, but what you are seeing is X, right? This impact on your developers, on the ability to get things out, on what is it that people do see that then you can work with them to say, okay, here's why we see that as connected to this, this particular subset of bottlenecks or these more specific problems in the flow.
That's a really great question. And the thing is that because this is, I'm a big fan. I don't know if it's clear enough to see my bookshelf here, but I've got the Goal, I've got the Phoenix Project. I'm really inspired a lot by the simple theory of constraints approach to productivity, that if you can have a process that's going to increase throughput and decrease cost, then you have a process that's going to help the business win really at all levels of the organization, which is what developer productivity engineering focuses on. So because we are, for instance, eliminating things like idle and wait time, or at least reducing that for developers, and also reducing their need to context switch between various tasks by keeping them in this flow state more frequently, what you see is developers actually asking for feedback more frequently. If a developer can run a build in 10 seconds as opposed to 50 seconds, a lot of people might look at a 50-second build and be like, oh, that's great. But what if that build could be 10 seconds? In that same span of time, a developer could actually ask for feedback 5 times as often from their build. So they're more likely to submit a smaller change set when they actually do like when they actually push something out, maybe to CI for a build or wherever. When they actually run the build themselves, they're going to run a smaller bit of code at once, which is going to lead downstream to things like less merge conflicts, right? And less merge conflicts means less work by build release engineers having to resolve those conflicts, which then has a direct impact on time to market and productivity. But then other things like developers being able to refine their work more frequently means that they're going to find bugs further left in the process, which we all know and love because they're able to run their test cycles more frequently when they're able to have the tooling accelerating. So that's going to have a direct impact on quality and ultimately brand. And then there's also the whole issue of employee retention, which I think is something that has been a particular importance to the industry over the last couple of years. And that, knowing that you have developers who take a look at the build experience and say, gosh, none of my buddies are having to deal with this kind of thing. I think I might go work somewhere where they're really focusing on the ability for developers to be more productive. And we've particularly seen this resonate in some of the mid-markets and folks on the other side of the chasm, if to forgive that metaphor, but businesses like that are trying to figure out how can we invest in ways to really have our developers love what they do at their job at our company. And one of the best ways that you can invest in that is by implementing at scale within the organization a developer productivity engineering plan that then says, oh no, this is going to be a delightful place for you to work. Our builds are super tight. Our test cycles are really tight. You got great tooling to help troubleshoot when you do run into failures. We've got failures plastered up on a dashboard, and we understand how many developers are impacted by these failures and how frequently and how long do they have to wait to encounter this failure. So we have all of this available to you, and we've really invested heavily in the experience. So I'm talking to a C-suite. The easiest thing I can say is, oh, I've got a product that decreases cost and increases throughput in every case. We could end the conversation right there in a lot of cases, but then to be able to really flesh that out into what that means, how do you cascade improved in idle wait times and faster troubleshooting out to really all the top C-level initiatives in the company? It's not hard to connect the dots, and all the mid-level VP director and VP and director level initiatives are often they meet in the middle of a better developer experience and C-level objectives.
Totally makes sense. You're certainly not going to hear disagreement from me on, faster feedback cycles, hearing more, learning more. But as attuned as I am, you use the word failure about 55 times in that description. And it's interesting because I've spent a lot of time in the season talking about failure in the we tried to do a thing and didn't go to plan. But but if you go to the extreme of test-driven development, it's like I'm going to intentionally create failure until I have success, right? And so it's a little bit of a nuanced shift in the use of the word, but almost in a way that doesn't matter, because if I take that approach and apply it to bigger things, it's actually a great way to look at it, right? Like this is just a tool in which I'm validating that I haven't found the answer yet. And knowing that I haven't found the answer yet is a good thing to know. And I'm going to keep going until I have the answer, right? And that might be this little algorithm, and it might be something much bigger than that. In all of those cases, fast feedback, like whether it's one function you're writing or the business that you're building, the faster you can learn you're wrong, the faster you can get to right. And so is there a cultural element as you look at sort of your customers, people you're talking to about this? You said it's super easy to connect the dots, but honestly, not everyone just looks at that and says, oh yeah, got it. Let's go. So is there something about organizations that you're seeing, kind of jump on this that already have some of those other pieces in place, or something about them that stand out in terms of embracing that? Like, I want to learn as quickly as possible, and this is going to get me there.
I think so. I think that there are organizations who are able to differentiate engineering toil from unavoidable failures that actually make the product better. right? I mean, writing, for instance, a test that you know is going to fail for the first few cycles until you get it right, that has engineering value, right? That's not an avoidable failure that could have just been eliminated and pulled out from this developer in the first place. So I think organizations that have done a good job at like defining and recognizing toil versus failure that actually has an engineering value, that is a cultural thing, right? It's not immediately obvious to everyone, right? So thinking about that in more of like on the ground, what does that really mean? Let's say that for instance, there's a flaky test. There's a test that sometimes produces successes and sometimes produces failures for developer. And if we were able to detect that the test was flaky and put it on a dashboard and be able to see how flaky it is, how often is it actually impacting developers, then we could actually say, okay, well, we're going to do something today about this flaky test because it's impacting this many developers and it's causing this much toil in the organization. That's an example of a possibly avoidable failure, right? If we're able to fix this test flakiness and maybe even set it so that it only fails when it's actually going to provide valuable and interesting feedback back to the developer that has engineering value, then we've eliminated toil, right?
Mm-hmm.
There's even more common ones. So let's say that you find out that 500 developers a week are failing on what we would call a non validation or non verification test, failure, I should say, where verification failures are things like this assert failed, or I didn't have this class in my class path. And other failures would be failures like, oh, I had a web server to try to go to test some API, and I just got a 500 error or a 404 or something, right? The web server was down or something like that, right? Well, that could have been avoidable, if there was better site reliability on, that web server, and it could certainly be improved. But again, if it's only a couple of developers like in their local build environment running into this failure and no one's actually tracking it, then it's probably not going to get risen up past that developer's workstation. They're just going to hit it again. Oh, it's failed. Oh, okay. Maybe I'll skip this test this time. That's more the psychology for getting the work done. But if instead we could identify, no, this is affecting 500 developers a day, and it's impacting 500,000 builds a week, and it's taking developers 5 minutes, to get to the point in the build where the failure even occurs. Well, we can proactively eliminate that. We can then, just remove this toil altogether so that the developers never see it. So I think, yeah, it really comes down to defining like what's a constructive failure that actually adds engineering value versus what's just toil that could be avoided.
Yeah, I think it's a really good segmentation, and I was trying to think about recasting it a little bit as failures that have useful information, but I actually came to the conclusion they both do. They just have information about different kinds of things,
Mm.
right? Like information that our process or system could be improved versus information that there's something wrong with the code I just wrote, right? And particularly the former, you want to collect an aggregate is what I'm taking away, because if every individual is like, yep, the system could be improved, but just keeps that to themselves, or it's kept in their local build environment, then nothing is gained from it, right? Because each individual is like, this is just a minor nuisance for me, but the total cost, right? Now putting my CTO hat back on, the total cost across all of those engineers in terms of everything you described, just specifically today, plus the every day is frustrating, doesn't look like my friends at this other company have every day be frustrating. Like, let's talk about that. That cost in aggregate is quite significant. So as we wind things down, I want to jump into this red build rewind. So it's my
Yeah.
favorite part because I love the stories that people bring to this. But can you tell me a little bit about a situation where something didn't go to plan for you, and whether it's career, technical, whatever, and maybe felt catastrophic at the time, but ultimately you learned something really valuable from it?
Yeah. I actually, so I knew that you were going to ask this question, and I struggled a little bit with it. I was like, okay, what do I tell? Because, I mean, there's this, what do you focus on? Like a personal catastrophe, but I think I just would end on something maybe super technical. So, I mean, I'm going on, over, gosh, just 22 years of professional software experience in one way or another. I mean, I spent, the first 10 years of my career slinging code and then moved more into architecture and systems integration work. But my first real programming gig was for MindSpring, the ISP in Atlanta.
Mm-hmm.
And so this is going to be back in the early aughts that I was programming for them. And I was working on a language called WebSpeed, which is a progress technology that's still around. And so it was an early like 4th generation DSL language. And at the time, we were one of those companies that were still writing their own billing software, right? So we had, WebSpeed is like a very kind of database driven, it was like at the time kind of visionary. It combined like the model view control and the database all in one language. It made it super easy to hit. What that also meant that the fulfillment database and the sales database and the backend billing database were all the same database. Right? It was the way that WebSpeed was sort of architected. Now I was working on sort of the customer service and fulfillment side of this, but that meant that I had access to things like the billing tables and things that really shouldn't be messed with if we want to be able to collect revenue from our customers. And so I was doing, typical hacking around in the console, had a production window open, had a development window open. I run a query to clear out my billing codes from my little sandbox that I'm running in, and I hit go when I realized I just did that in production. I just nuked all of the important billing codes that help calculate what our customers actually owe us on our bills. And at the time, I didn't realize that I had done it in production. So I closed this thing out and I'm just like, whatever, done with the day. And then the following day, I get this, what the hell has happened to our billing system? Why didn't any of these invoices go out? And so I'm like, oh, I was playing with that table and it was not in the environment that I thought I was in. So a couple of things happened at that point. First of all, my heart sank into my, pants. And I was like, oh man, I've just really screwed this up. I'm a new developer. Like I'm just gonna be fired for this and everything. The second was I need to tell somebody immediately that this happened, right? I need to just fess up and be like, look, here's what I was doing so that somebody who knows these tables can go and recreate them and fix them. And so I went to my boss and told him what happened. And I did not get fired. I ended up staying there for another almost 9 years of my career, actually, was working for that company. We were able to restore the billing tables very quickly once they knew exactly what had happened. And I was told, the bit of wisdom, hey, everybody gets one big screw up around here, basically. So what I took away from that as a young developer was really like the importance of transparency when you're dealing with an engineering problem, right? If I could have sat on that and maybe they would have audited it later. We didn't have the best audit tools in place, or maybe I could have beaten around the bush a little bit and be like, oh, I don't know. I was playing with something, but instead just saying, nope, this is what I ran. This is why I screwed it up. We were able to solve that problem very, very quickly. And I think, to this day, I remember that moment when we're faced with the same challenge that I think we all face in our daily life. I just screwed something up. Should I tell somebody about it? So.
Yeah, I mean, the outcome from that is amazing, right? Like, I think those are great takeaways. It's most important thing is there's a problem and we need to solve the problem. Yes. I have more information than anyone. I'm nervous about sharing that, but the best thing we can do for the organization, and honestly, the best thing for me in the long term is share that information. And in the right organization, right, the question is going to be, why do we have a production database where someone can accidentally delete all the billing tables? Like, let's ask ourselves that question instead of, what's wrong with you, right? Which is a shift that it's taken us probably the course of that story, like from when that story happened to now, to really acknowledge this is going to happen.
Yes.
So how do we, my takeaway earlier in my career was setting, PS1 or whatever, like all my prompts said, you are currently in production, be very careful what you do, whatever.
Oh, yes.
Like learning to always do things in a transaction so I can roll them back until I'm super confident that I did the right thing. There's other more technical lessons, but the real question is, why does someone have a production database open on their, in a terminal that's just started in their job or whatever? Like, let's talk about that. Let's think about what we can do to make that not happen. Because someone's going to hit enter in the wrong. It always happens when there's no check. So
spot on. And all those things happen, by the way. And I learned to set the background of my putty terminal to like bright, obnoxious red later when I was in there. So yeah,
you are in production. Do not forget.
Yes.
Yeah, absolutely. Absolutely. Love it. Well, thank you so much for sharing that. Thanks for sharing everything else. I mean, developer productivity, near and dear, learning from everything that's happening in your environment, and building software. Also something I love to talk about. So awesome having you here today. Thanks so much for sharing. For everybody who joined, is listening, thanks for joining us. Subscribe on your favorite podcast provider. Tell your friends. And if you want to hear anything from us or have us talk to anyone in particular, find us on Twitter at CircleCI. Let us know. Justin, thanks again so much for joining.
Rob, it's a pleasure. Thanks so much for having me.